So, hello, could you hear me well? What do you think? Perfect, thank you. So, my name is David. I am originally a Java developer. I do have some Kubernetes knowledge, backed up currently by some of the CNCF certifications, so we can talk about this if you're interested. And currently, I am working as an infrastructure engineer. So, what about a short poll? So, who knows what the Postgres is? Please raise your hand. OK, there are some that didn't, maybe, sorry. Who knows what Patroni is? OK. And who knows what Cloud Native PG is? Perfect. You will, fortunately, learn a bit. So let's start with something very unpopular, right? Is Postgres a distributed system? And if it may seem so, like an obvious answer, right? Well, it's not that easy, I would say, because if you look at the Postgres, originally, of course, it was not designed to be distributed. And what do I mean by it? Typical, current, like modern distributed systems allow you to shift, for example, the writes because you need to some nodes, because they are more performant, etc. Postgres does not allow it. So basically, it has just an import-export functionality. You have a leader, which is able to write, and you have replicas, which are able to follow the leader, basically. Also, there is a problem that Postgres itself does not offer a good way how to connect your clients just to the reader for the writes. Because if you connect to Postgres, it might be a primary, it might be a replica, who knows, right? Is it easy to sync the data between the reader and the replica? Well, maybe so. Is it easy to sync data between the replicas themselves? Well, typically no. Can you serve only a partial data set? So, for example, you have a large, let's say, audit archive table that you don't want to have in your small but still performant reader. This is not possible, right? Can we have multiple readers in Postgres? Sure, you will see later on. And do I have some, let's say, assurance that I will connect to the leader only? Well, unless I'm using libpq, which is like the default implementation of the client, it's kind of limited. And what do I mean by it? And what I'm trying to get to? There are other systems. I have, for example, selected Apache Kafka, which is quite different, that if you install just the system, there are, let's say, batteries included. It is allowed to do a lot of the distributed problems, solve it by itself. I'm specifically comparing to Apache Kafka because it was not always this way. There was a zookeeper which acted as a distributed, let's say, source of truth before it, but they have refactored Kafka to use the Kafka only itself, which is interesting. For Postgres, on the other hand, we don't have such a thing, right? So typically, if you are like a suicidal a little bit, you are running just the Postgres with no extras, but typically people in like professional way run it under Patroni management, or maybe currently with some Kubernetes operators, you know. But still, there is typically another distribution that is even above this to cover a lot of other aspects. So we will talk mostly about the physical replication. This is a thing that is built in from Postgres for decades, I would say. There is one single number that is database system identifier, which is created at the start of each initdb, let's say, run. And this is basically some timestamp, and we can call it, let's say, a random number for us that identifies the cluster itself. There is not much else that the cluster is identified by. If you have a different instance, you need to understand that this is basically a clone of the original one. And by clone, I mean that you need to follow the path of every change, every write that there was to the data files. What does it mean? So if we basically lose any write in between, we have a corrupted WAL file, we lose the WAL file, we are not able to follow, right? If there is any gap, we are just stuck, and we need either another snapshot, or we need to fill in the gap, for example, from the WAL archive. If you think what the replication slot is, typically, so if you have a physical replication, each replica keeps a pointer, let's say, on the primary to see, from the primary's perspective, where the replica is at from the writing position. It is just a pointer. It's basically nothing else, and it's typically affecting like the WAL file management, let's say. So the primary does not lose the WAL file that the replica has not yet transferred to itself. This is, of course, very different from the logical replication, which we will not cover today. The major theory that you need to know around physical application is the LSN, log sequence number, and the timeline concept. So the LSN is basically very simple pointer, let's say, in linear memory to your current writing position. Or there are actually multiple like PG functions that can tell you either where you are currently at or the next position you will be writing to, something like this. You don't like think about this in any sophisticated manner. So we can do kind of, let's say, cool stuff with it. And the timeline basically is how many branches there were, meaning how many recoveries there were in Postgres level. You will see later on maybe a better example than this like theoretical one. So if we have a Postgres that is constantly writing, at some point, it is, let's say, on the timeline 1. This is the upper line. And at some recovery event, you promote the replica, and the timeline switches +1 to number 2. The whole long number is typically the number of the vol file it is writing to. It is consisting of 2 parts. The first is the timeline ID, the second one is LSN. Very important part here is when you branch the timeline, when you do the recovery event, the LSN does not change. So we are continuing from the one to the next. As I mentioned, there are 2 functions. Either you can tell at which position you are currently at, or you can tell which you will be inserting to. But the LSN is basically an offset in bytes, how many was written since the beginning of the Postgres cluster. So we can do some basic calculations. If we subtract something like 0 LSN, like the beginning of time in Postgres terms, we know how many bytes were written. Also, if we need to compare 2 LSNs, we can do this with the subtraction kind of easily. And there is a way how to tell that what is your size system identifier, timeline, etc., what is your current vol file. So we can get every piece of the information from Postgres itself. So if you are running Postgres and you have a kind of a disaster, right? There are typically 2 dimensions that you look into. One is recovery point objective, and this is what we are most interested in because it tells typically how much data since the last checkpoint, backup, or any, let's say, persistent event you will lose up to the point where the crash has happened. Typically, it is called the replica lag because this is the lag when you are streaming the data to the replica. What is the, let's say, the largest difference that there was in the time of the incident? And it is typically measured in bytes, which is very important. So if you have a busy system, typically you tell, OK, we are able to lose, I don't know, 1 vol file, 16 megabytes, or something like this. There are, of course, it is also dependent, let's say, on time slightly. So if you have a low volume system, typically there is some, let's say, enforced event that will send the data so you don't lose like much of the time, but the vast majority is measured in bytes. For the following examples, I do have 3 colors for you to understand. So typically, PG red is the hostname of the leader, blue and green are replicas that follow. So first of all, there is a function called PG is in recovery. On the replica side, you can tell if the replica is in recovery, and there is a table called PG statval receiver that is able to tell you some, let's say, more details around it. So we are receiving vol files from the primary, and there are several LSNs that we will cover later on. Also, there is a function, if you would like to make a promotion of the replica to the leader called PG promote. If you are already promoted, there is some error, but typically it works like this. Let's say that it's kind of easy to do a promotion. It's an event that does not require a restart, so it's kind of typically it's very fast. Is there such a function as PG demote? So if we are able to promote online the replica, are we able also to demote the leader to follow under the replica, for example? And the answer is simply no. There is no such thing. And basically, it is controlled by the several config values. 2 of them are the most important ones. So you have, if you would like to have a replica, you need to set a connection to your leader, and typically, or you need to set also the replication slot name, so you know which slot do you follow. There is also a file in the data directory called standby.signal, which is like signaling that currently we are the replica and we need to follow. With this, you need to restart the Postgres. So the blue was a leader before. We have stopped it. We will input this, and then after we start it, it will start to follow someone else. Typically, when you have a distributed system, you have a problem that it is very hard to tell who is currently the leader. A lot of publications is already known about this. There are typically two algorithms that are able to manage this, and it is, let's say, for our purposes, managed outside of the Postgres. So in the Patroni use case, typically Patroni tells it's a distributed configuration stored, and typically it's etcd. It can be the Zookeeper or some other systems. And what do you get from them? From all the nodes where you are Postgres, if you ask them, they will tell you exactly the same answer, who the current leader is. And the new leader, if he's being promoted, he can have a log, so you know that no one else is being promoted at the same time. Basically, this is the only thing that matters from these systems. If you run Kubernetes and some operator, typically the kube API server will take care of this. There is some release mechanism, but this is basically very similar to what Patroni uses. Behind this, there is also etcd. You need at least 3 nodes to have a highly available setup, of course, but you can go with only 1. If you typically run Postgres on your own, maybe you try to help yourself with some monitoring from a single machine. It might be also possible, but you don't have the high availability, right? So let's start with a very basic thing. Let's create a Postgres cluster. So we run initdb, right? And then we need to bootstrap replicas. We have discussed that the replicas are an exact copy of the leader from the byte perspective. So I will show you the 2 possible ways how to do it. First, there is the initdb, and there is a command that is very simple. We just have a separate -k parameter, which is for checksums. By the way, another unpopular opinion is that I think this should be the default, but let's skip it. So you will have a database cluster from now on. You can start Postgres there, right? Then you can create a replica. So a typical way, you SSH to replica if you use VMs, and you run something like pg-based backup. Just for you to understand, the checkpoint needs to happen on the leader. So there is an option to enforce it with fast. You can decide if you would like to have a replication slot or not. I would suggest that typically you would like to have a replication slot unless this is a very low volume system. And basically that's it. This is typically very fast. It will transfer all the data that there are on the disk. Typically it will also transfer the WAL files, and you are good to go. As you can see, in the generated replica directory, there is the file standby.signal, and those special parameters for replica, for connection info to the leader, are stored in the Postgres autoconf. But let's try it another way. If it's just a copy of the leader, we can use something lower level, right, to try to create it. So for this approach, we have 2 sessions. In the first one, we log to the leader. We create a replication slot that we will use later on, and then we call pg backup start function. When the function is active, we are able to just copy, plain old copy and data with cp, rsync, and anything basically you like. This is very interesting, how easy it is, let's say. And when we are done, so after the copying, we will call pg backup stop, which will tell Postgres it can continue, resume normal operation. And as you can see, we are able just as easily to follow. In this setup, we of course need, because when we copy the directory from the leader, we would have a leader there. So we also need to create those 2 config options. and touch the standby.signal file. So let's try an exercise and promote everyone, right? Can we do it in Postgres? Yes, we can. Why not? But this is a very stupid thing. It's not the multi-master that so many of us would like to have, but this will create a split brain scenario. So Postgres is like individual instance, and nothing is preventing you from running PG promote at any time you want. And from this point now on, from these LSNs, basically you are on your own, the replicas are not catching up, and you are basically diverging in the timeline. So it means that each of those nodes is basically a separate Postgres cluster from this particular moment. But this is not a smart thing to do, right? So just to maybe explain very basic stuff, there is a Vol sender process on the leader that is able to stream the Vol files to the replica. You can follow very easily through the process name at the current LSN position it is at. And on the replica side, there is like analogy to the same stuff. So there is a Vol receiver process that is receiving the replica to the replica. Okay, how do we see what is happening behind the scenes from the PSQL? So from the leader perspective, there are mostly two tables, PG replication slot. This is on the left side. There can be multiple slots because we can stream our Vol files to multiple replicas if we like. Why not? Each of them should have a separate slot name. Basically, they are managing the slot from their side. And there is also PG start replication with some details how the replica is doing. So these are mostly the information, like the last known information from the replica side, how much of the Vol file was already received. On the replica side, there is a PG start Vol receiver, which I have shown earlier, with like mostly the same numbers. So you can tell just from looking at those numbers. You can see the LSNs, so you can calculate the byte difference between the leader and the replica, and you can also tell how much time has passed between it. If you run something different above Postgres, like Patroni, this is the typical status command output. So you can see in this status that we have clustered 3 nodes. There is no lag to the replicas, and we are on timeline with ID number 5. For Cloud Native PG, the status command for your Kubernetes installation is slightly different, but everything is there, right? Everything from the previous commands, all the LSNs, all the time drift, etc. What file we are using currently, everything can be diagnosed from here. But I would maybe like to focus slightly on cluster status. Because what does it mean that your cluster is healthy? This is one line of the Cloud Native PG status that you will get. Typically, it means, or what should it mean can differ dramatically, right? From the source code, I have investigated that for Cloud Native PG specifically, this means that the leader is online and there is no replica in creation, which is kind of I don't know how to tell. There are many different failure scenarios that can happen. You can see that the, people complain about this, that what should be maybe included in the cluster health, because from our perspective, we want to have just a simple semaphore, right? Red, that something is completely wrong, maybe it needs some manual recovery or something like this. Yellow, that maybe we will be in the red soon or something like this, and green, like nothing else. And with Postgres, as a distributed system, with each node having separate stages, etc., it's very difficult to tell and have some kind of consensus what might be the current cluster status. Okay, just to briefly mention replication conflicts. So if you have a replica, there are 2 LSNs that typically are being watched or should be monitored at least. One is the flush LSN, and it tells, okay, we have transferred Vol file and safely persisted it to our disk. This is the flush LSN, so we won't lose this data no matter what. But there is a second one, which is called replay LSN, and basically it means that it is not just stored onto disk, it is also applied to the replica Postgres. So you are able to see the data in Postgres. And these might be, of course, very different. Typically, if you have no such problem, it's like under 100 milliseconds, something like this. But when we try to create some situation that would cause a delay, so for example, I'm running a PG bench on the leader, so the vol files are being constantly generated to the replica, and I want to create some slow query on the replica, just to tell, okay, we will be lagging behind. And in this case, when I also set max standby streaming delay to 100 milliseconds, this will tell Postgres to kill my query if they are 100 milliseconds or more slower than the replay should be. So in this case, on the replica side, it will kill my slow queries. Why is it? Because typically you want, or there are several use cases, but if you have, let's say, a live replica, meaning that your application is writing to the leader and doing some selects on the replica, you would like to have the most fresh data you are able to, right? And in these cases, you would like to have the smallest possible difference between the flash SLSN and the replay SLN. If there is like 1 minute gap, it might be a problem for you. So this is just showcasing how difficult it might be to get. Let's try a simple switchover. So this is basically an event when you have a leader and you would like to transfer the leadership, the writing ability to former replica. So we have a leader, we have 2 replicas, right? We stop a leader, we need to wait a bit so the replicas catch up with these LSN, so they replay, they flush, and they replay all the information. Then we choose who from the 2 replicas should be in your leader. This is non-trivial. We will discover it in a bit. And then we, on the new leader, create a replication slot, and we will switch the old leader to the new leader and the second replica to follow the new leader. So we don't lose any data here. I will show you step by step how does it work. So pgred is our current leader. We shut it down. And we wait a bit. This is very important. So from the pggreen, who is replica, we see that something problematic is going on. So the leader was shut down. And basically, before we promote it, we create physical replication slot for both of the new replicas. This is important to do because if we wouldn't do it, and there would be like a lot of vaults written, we might lose these files in the process, depending, of course, on the configuration of the Postgres. So we promote after we create replication slot, and after we do the PG promotion, the PG green node is ready for writes and is the new leader in the cluster. At this point, the PG red is disabled. It was the old leader, so we need to turn this into a new replica, right? How do we do it? So we touch the standby.signal file. We input the 2 primary coinfo and primary slot name parameters there. Then we start Postgres. There is a very important part that there are no further writes on the old leader. We will discuss it in a bit. If we would like to switch a leader for the replica, which is already a replica, it is very easy. We just switch the connection info parameter, and we just reload the configuration. And from now on, it is following someone else. No problems here. OK. There is, of course, slight problem, because if you use logical replication or some data capture parameters, and you have some slots on the primary that are not transferred at all, right? What does it mean? Typically that your like depending system, your secondary system that is relying on the leader won't know its current writing or reading position on the new leader. So in that case, you typically need to transfer them. I have just copied from the documentation how does it work with Patroni and Cloud Native PG in comparison, and it's basically advanced. It's like very similar. So they typically copy the slots to all your replicas that are eligible for promotion, and they advance it via some chrono-like mechanism periodically. So one thing that we can maybe enhance is that when we need to switch off old leader, we need to wait for a shutdown, right? And first thing that we can do an explicit checkpoint before we do the shutdown, meaning that we flush all dirty buffers to disk. This is typically like a speed up in terms of minute. And then we can also discuss like which shutdown modes we use, because the immediate may be too aggressive here, but we can still decide if we would like for our clients that are already connected to continue their work and finish it safely, or we just kill and disconnect them. For example, Cloud Native PG has some combination of these shutdown modes. So you are able to tell, okay, let's say for 15 seconds, let's wait if they will close their connection like gracefully. If not, after 15 seconds, we will kill them and they just wait for a shutdown. When we would like to select a new leader, who of the two replicas should it be? It's not a trivial question, right? And especially if you have some kind of different setup. For example, you have an asymmetric VMs or something like this. One is faster than the other. So there is kind of a recent feature in Patroni that you can set up a failover priority, meaning that one of the replica will have a preference over the other, but there is always a condition. They both need to be caught up, meaning that they all need to be, let's say, have all the vol data from the primary. From the Cloud Native PG, there is no such function. So basically, it takes the random one that is like the most recent. If you have still some asymmetrical instances, so imagine a scenario that you're running one leader, and for maybe some economical purposes, you're running just a very small replica. Are you able to do the switchover? Yes, but there are some Postgres settings that needs to be at least the same value or higher for the replica to do the failover. So just bear this in mind, because typically this might be kind of a problematic, I think. But hopefully this is much more of the historical use case, I guess, and it's not a very recent one. Okay, let's think what might go wrong here with the switchover. But basically we have already covered the possible problems, right? If the replicas are not caught up, this is the problem. So either the replica has been shut down for a while or was not accepting new vol files, or either the replica is, for example, not fast enough in replaying the vol files. This is also the problem. So basically, if the LSN difference between the leader and the replica is, let's say, manageable, I don't know, under 50 megabytes or something like this, typically this is okay and you can do it. Otherwise, you need to decide if you would like to wait in this, let's say, incident situation, maybe a bit longer, so meaning that to wait for the vol files to be transferred correctly on the replica, or you just promote and lose some data. Of course, there is only one solution to this, and this is monitoring. Let's now talk about the failover. So in the switchover, this is the event that a system administrator wants to do. In a failover event, this is something, let's say, like an incident that we were not planning to do. If you go through the scenario, it is very same, except, excuse me, for one thing, that you need to make sure that the old leader cannot start, is dead, is cordoned, fenced somehow, how do we call it? Because if there are any new writes there, you will have a problem. Excuse me. So the only difference is that you need to make sure that the new leader won't receive any new writes. And basically that's it. So let's do, again, some stupid things, right? Let's remove every file from the Postgres data directory. And on Linux, this is, of course, not a problem. So the database is even able to like gracefully shut down on the leader, but still there is some problem typically, right? So let's assume that the leader has failed. From the replica side, we can inspect like at which situation we are currently at. So we don't have the current vol insert LSN, because this would need to be a leader to execute it, but we still have the same functions as we have seen in the status. So the replay and receive LSN. So these are basically the LSN we can decide upon which of the replicas is the most recent. So on both replicas, we basically run this command and compare the LSN. The most recent one should win. For the leader fencing, this is a very broad topic, and I would say that this is the differentiator between how do the different Postgres product distribution behave, because it is a very rare event, it is very difficult to test it, and it is the thing that can decide, okay, if you need to recreate your failed leader for maybe one day, if it is larger, or if it is no problem and it can be turned into replica instantly. There are different approaches to it, and we will see later on. So let's try a simple failover if we would like to promote a new leader out of the replica. This is, again, the very same procedure as we have seen previously. So we choose a new leader. On there, typically, we create a replication slot, we do the PG promote, and then on the other replica, we follow the new leader just by switching the configuration parameter and reloading the configuration. Very same. So let's imagine that it does not work as expected. So, for example, the old leader is taken out of the network, but there is some vacuum, maybe from cron run or something like this. So there is anything written there. We will typically result in a split brain scenario, meaning that our WoW file timelines has diverged logically, meaning that there are different leaders at the same time from the LSN perspective. So let's create a very simple split brain scenario when we have two leaders, right? So PG Blue is the leader, it is still a leader, we don't do anything with it, and we promote PG Green, who was a replica originally. We can do it, right? And now from this LSN, we will have a split brain. So this is the starting point of the problem, let's say. Simply put, there is no way how Postgre can merge it together later on. This is basically why we want to take care it does not happen at all. If we would like to demote PG Blue, which had some, let's say, problem, and we would like to follow the new leader, this is how it might look like in the console from the logs. So we can clearly see that the timelines have diverged. And for the old leader who has some additional rights, it is not able to create some mechanism how to follow it. So how to detect that we are in this situation? Well, I've, of course, asked Postgres AI, and this is the result. Select from PG timelines. Unfortunately, there is no such table. So AI didn't help much. And to be honest, this is not very clear to me how to do it correctly, because for, of course, ultimate verification, if you're able to follow a leader, is that you connect to it and you just follow it, right? But only thing that you are able to get from Postgres, basically, is your timeline ID, and there is a file, the history file, in the data there, of the last branching. But, you know, if, for example, you are in a situation where the branching has happened at the exactly same time for multiple replicas, what happens then, right? So let's try to simulate such a scenario. So, in this scenario, we have three nodes. We have, again, PG Red, who is the old leader. We have Green and Blue, who are the replicas and following the PG Red, right? Easy, so far. Then we try to stop PG Red, let the replicas catch up, and promote both of them at the same time. What does it mean? From the Postgres perspective, the branching has happened at the exactly same LSN. So the, let's say, simple check that if you are able to follow later on the leader, probably will go through, we will see later on. And so we are currently in the situation when if we have a split brain created from the exactly same LSN, we write some data of a, let's say, similar amount to both of the new leaders. Similar amount meaning that we will try to confuse Postgres, but when we will try to make one of the leaders follow each other, that it is basically on a similar, let's say, position of writing. And we want to know if, at the end, if we make one of those leaders follow as a replica, if it is able to do it. And basically, you can see the result here. So the PG green was promoted. It was being kept that way. PG blue was promoted. And at some time, it was stopped. And we made it follow the PG green. And this is the error that we have. This is the error that, for example, I am not able to decipher much. But as I understand the situation, we have just basically corrupted our vol files, meaning that Postgres thinks that everything should be correct. It is trying to follow the new vol files, but there is some logical difference in them, so it is not able to do. So this is maybe just another example when I talk that Postgres, like safety measures for the distributed system are might be, let's say, slightly updated, something like this, that you are able to do such a stupid thing, but of course, at this point, it didn't work. Let's maybe talk a bit about the leader fencing. So you are in a situation that your leader has failed, and you would like to wipe it out, basically, to close it for other connections or do anything about it. So if you are running VMs, you can, of course, work with systemd, block the service, for example, for starting. So after the restart, it won't start up again, something like this. You can disable the VM on the VMware level. You can take it off the network, whatever you like. If you are running Patroni, the typical logic is that it tries, if it doesn't, it, let's say, restarts and think it was the leader originally, it checks if it should be a leader again. If not, it will demote the Patroni process and it will shut down Postgres. So this is a protection, so the Postgres won't get any writes. But these events typically take, I don't know, under a minute or so. So if there are some clients that are already in the connection process and you are already failing over to some other replica, typically it doesn't work well and you can still get some writes. On Cloud Native PG, the situation is similar. However, the naming terminology is kind of different because fencing, in their perspective, means that you would like to have a pod running without the Postgres itself for some, let's say, inspection or analysis. If we would like to rescue the old leader, so let's say we are in a situation that the old leader has some additional rights and it is not able to follow a new leader. What can we do? So basically, we can kill it completely, wipe it out, and create a new replica on that VM. It is possible? Yes. If you have a large database, of course, this might be taking a little bit longer. This is a problem typically that we want to solve better. So both Patroni and Cloud Native PG support like 3 ways. PG-based backup is the let's create it as a fresh replica approach. PG rewind is some tool that we can use, or maybe you can also try to create some recovery from your backups and let from the whole archive to catch up, something like this. So a PG rewind is a tool that is allowed to do and help you in these cases. So basically, if you have a leader that has some different rights to your new leader, you are able to rewind and sync to the same position of the new leader. This is how it works. It can fail. I will show you now. So what it does need typically are all the vol files for the divergence. It needs to have some Postgres settings like data checksum or something else to be turned on. And I think that typically this implies that you need to have some kind of a vol archive or something similar, because if you don't have enough vol files, you will get an error such as this, that it is not able to follow. If you do have a lot of vol files, this is the procedure. So you stop the old leader that you would like to recover. Then you run a simple command, pg rewind, pointing to the new leader. And what it does, basically, it inspects all the data files that have changed on the new leader, because he knows the vol files. and copies them from the leader, from the new leader to the old leader. So as you can see, we are trying to recover a cluster around 300 megabytes, and it is copying around 80% of the cluster. This is the workload that I am using some PG bench on. So typically, if you have just a single table that is under heavy write load, you won't get much from it. If you are in a situation when, for example, you have some append-only table, like for archival purposes or something like this, and there is just slight drift at the end after 4 terabytes, it's very different. It can be a lifesaver. So you can definitely use it for the busy systems. It is maybe not that useful. And one of the problems there is that Postgres basically after restarts keep the same settings. So basically it means that if you have some kind of incident, you have a crash, the Postgres, who is a leader until then, thinks also that after restart it should be a leader. And let's say in vanilla core Postgres, there is no way how to turn this off, how to go around it. With Patroni or Cloud Native PG, there are ways how it can be approached. And basically, there is some other process that needs to check before the Postgres itself is started. What is the situation? Am I still the leader? Shall I start like normally? Or shall I be demoted and not start or recover or something like this? There is also one very interesting situation, because we discussed that we, for this decision, who is the leader, constantly require a single source of truth. But this might also fail, right? So we are not able to connect to the etcd to tell who is the leader now. And in this situation, it becomes like very tricky what to do, and it is about your, let's say, preference. What should you prefer? Because either you are safe, you don't lose any data, but if you are not able to tell who is the leader, it might happen that some other leader was already promoted, so you would demote everyone, basically, have everyone as a replica only, so you cannot accept writes. Or you keep the current state, but there might be some other leader who is being promoted, you know, and at that point you will have a split brain. So you just need to decide. Again, very like insightful approaches from Patroni. There is other mode called failsafe mode, which is able basically, even if the etcd is not available, try to connect to all other nodes and check their status with the direct connection, which is very like interesting and I would say very practical. In Cloud Native PG, your source of truth is the Kubernetes control plane. So if you have a trouble there, it basically does not matter much, because without the control plane, you cannot run any pods, you cannot kill any pods, etc. You cannot change anything basically to the pod. So you are not in a position to do basically anything around it. Also, very interesting is to check if the leader is healthy or not, because just the fact that we have a leader, it is being accessible over the network, might not mean that it is performant enough, it has a lot of disk space for upcoming operations, etc. Maybe also there is some problem on the VM level that it just got stuck or something like this. So there are multiple approaches from both Cloud Native PG and Patroni how this can be checked. In Kubernetes, typically you have liveness, probes, and other mechanisms like this that periodically check or execute some command inside a pod to check if this is alive. Patroni has a watchdog mechanism, so basically it tries to ping the kernel, I don't know, 15 seconds tops, something like this, and if it does not respond, the process might be killed and demoted, something like this. So this is basically some kind of safety measure that your primary is being responsive, that there is no problem, let's say, on the VM level or something like this. But of course, there can be glitches. So for example, if your system has some sudden load or something like this, you need to survive at least a few seconds. So this is much more difficult to answer. We haven't covered at all the very very important part of this process, and this is how do we switch clients from the old leader to the new one. There are separate approaches. Of course, you can go with some proxy, either on the networking level, I mean like an AJ proxy or something like this. You can go with some proxy that is specific to Postgres purposes, so like PG bouncer. It is called connection puller in Postgres terms, but basically it is a proxy that you introduce and you have some kind of switching mechanism there. PG bouncer is very cool that you can pause for a while the connections there, so the disruption can be minimal. Or you have a Kubernetes networking. So when you, on the service level in Kubernetes, switch to some other pod as the endpoint, there are some mechanisms how this can work also. So this is, for example, the approach from Cloud Native PG. So let's talk about the key takeaway. It's not about the Postgres functions, right? About the details, about the LSN calculations. Because when you look at it from like a daily perspective, it's likely that you have a failover plan, right? It's likely that you may have some backups and you have some disaster recovery plan. Maybe you also have some good monitoring, but you are less likely to not execute any mistake during such a, let's say, intensive and frightening incident. And you cannot definitely have downtime under 1 minute if you are just a person you want to sleep sometimes, etc. So the key takeaway is that we should use a proven tool on the VM level. It's either Patroni, and I apologize here because I am definitely not sure if this is the Patroni logo. It's kind of difficult to find. Or in the Kubernetes world, it can be Cloud Native PG. So if you would like to run Postgres, please don't do it with core. Use any of these tools or anything else that is suitable, that is proven, and that will be able to solve the switchover, failover events for you, so you don't make mistakes executing all of this. And that's it. All I had. Thank you.
Any questions? None at all?
From the debt master or leader, there's still possibility to use the PG control data utility, and we can get the LSN.
Yes.
Yeah. Should we expect if it's clean shutdown, it's replied on the slave instance, and can we check that?
So you are talking about a situation when we have, and let's say old leader in my terminology, it has crashed?
Or shut down cleanly?
We don't know.
Both is possible, yeah.
But we can read the WAL file to understand when the last checkpoint was, basically, right?
The PG control data utility on the former leader can tell us if the file is still available for read. So the question is how we might check.
So you might be in a situation that the WAL file was not transferred to the replicas. Am I correct?
What exact LSN was replied on the replica?
Oh, sorry. If it was replied, yes, we can switch.
And if it matches the PG control data LSN from the already shut down cluster.
If it matches and was replied on the replica, yes, we can switch.
So, and it's the flushed LSN or replied LSN?
Flush LSN means it was flushed on the disk. Reply means it is already in the Postgres. Yeah. So if the Postgres is, let's say, healthy, we can be safe with the flush LSN, but there might be some discrepancy there.
Okay, thanks.
Okay. I have one question. Is there a possibility to have the replicas always synchronized? Let's say in Oracle you have max protection or max performance. And
yeah, there will be a presentation starting just now for it from Mr. Kukuchkin, who is the author of Patroni.
Okay.
Also, maybe just a small advertisement, there will be also a presentation of Cloud Native PG, so if you are interested in Kubernetes direction, definitely check it out.
Hi, you said that it's better to use replications and create replication slots for the PG-based backup process. I guess the reason for that is that the old WAL files are not discarded before the replication is completed and replica is up
Yes.
and running. Okay.
That is the only reason, because if you have a lot of WALS files, let's say, kept on the leader, typically you can be safe, but I have definitely seen systems when the backup was taking so long that some of the WALs it needed were already discarded.
Thanks.
Okay, I guess that's it. So thank you very much. Thank you.
Thank you.